Welcome back. In this video section, we're going to go through example 5.29 and talk a little Djavals' rule. Let's get started. As we continue our review with contact lens, in this video session, we're going to go over SAM-FAP, residual or lenticular astigmatism, Djavals' rule, and then we're going to finish up with GP contact lens parameters. So let's get started looking at our text. So the first thing we want to talk about is SAM-FAP. So remember, what does SAM-FAP stand for? Yeah, that's exactly right. Steeper ad minus, flatter ad plus, right? And this is a way for us to be able to compensate for how we adjust the contact lens base curve. What do we need to do to adjust the power of the contact lens so they can still see perfectly out of that contact lens, right? So steeper ad minus, flatter ad plus. So if we make the base curve of the contact lens steeper, right, what's going to happen is we're going to create a plus tear lens. So we're going to have to add minus prescription to the contact lens so the patient can still see correctly or perfectly, right? And then for FAP, right, if we make the contact lens flatter, we're going to induce minus tear lens. We're going to add plus to be able to compensate for that. Right? Now, there is a way to be able to look, if you look in your text in that box right there, right, for every 0.1 millimeter change in base curve, right, we will approximately want to adjust the patient's prescription by a half a diopter, right? Now, not all of you guys use that. Some of you guys just work this out mathematically, and I'm totally fine with that. But if you like this, I think that's a simple way to be able to remember SAM-FAP and be able to apply it as we're going forward with examples. So let's talk about example 5.28. A patient is fit with a GP contact lens with a base curve of 8.0 millimeters and a back vertex of -3. If the base curve is steepened by 0.1 millimeters to improve the fit, what is the new power of the contact lens? Great, so did you get -3.5 as your final answer? Awesome. So remember with SAM-FAP in this case, we're steepening the base curve by 0.1 millimeters, so we're going to add minus to the prescription to get -3.5. Great. Let's continue on and talk about lenticular astigmatism or residual astigmatism. All right? So if you look in your text, you're going to see residual astigmatism is bolded there. You also want to write out the side lenticular astigmatism in case that's what you learned it as. So you kind of know that both those terms are going to be interchangeable. So mathematically, we can calculate residual astigmatism based on the equation 5.72. So that's the residual astigmatism equals the refractive astigmatism minus the corneal astigmatism. Now, let's take a step back and think about what exactly is residual astigmatism or lenticular astigmatism. Well, some people also know it as like internal. So my favorite definition for lenticular residual astigmatism is right here in your text in that next box, right? And whenever you think about residual astigmatism, what is that? It's all the astigmatism not attributed to the cornea, right? And so to me, that kind of helps me. I always thought residual and lenticular astigmatism was kind of like this like out there kind of concept. I was like, kind of what's going on here? And then I heard that as a student, I was like, oh, that makes all the sense in the world to me. So residual astigmatism, all the astigmatism not attributed to the cornea. All right, let's go to the whiteboard and work example 5.29. Example 5.29 says a patient presents with the following information. K readings of 45 diopters at 180, 45 at 90. Subjective refraction at the cornea at the corneal plane is plano -2, axis 180, right? The patient is fit with an on-K with a GP contact lens. What is the amount of residual astigmatism? So whenever we're attacking this problem, the first thing we got to do is we got to figure out, okay, what is going to be their corneal astigmatism? What's going to be their subjective astigmatism, right? And then we can use that to figure out what would be their predicted residual astigmatism, right? Now the first thing we need to do is to look at, okay, we're going to put these on power crosses, right? So we put the cornea on a power cross. We got 45 at 90, 43 horizontally. So we know the difference between those two is going to be 2 diopters, right? But now the question is this going to be a with the rule cornea or against the rule cornea? Yeah, it's exactly right, guys. It's going to be a with the rule cornea, right? Because the steep meridian is vertically, right? The flat meridian is going to be horizontally. So if we fit an on-K contact lens, what's going to happen? That means we're going to fit the contact lens, so it's going to be a 43 diopter base curve contact lens. So horizontally, the contact lens is going to be matching the corneal curvature, so there will not be a tear lens, right? What's going to happen in this vertical 45? Well, the 45 is going to be steeper, right, than the contact lens, which is going to be 43, right? So what's going to happen is you're going to get a minus tear lens, right, created vertically. So if we account for that in terms of the astigmatism that's going to be created, horizontally we're going to get no tear lens, but vertically we're going to get a minus tear lens, right? That's going to turn into -2 axis 180, right, for our corneal contact, or for our astigmatism at the cornea. Now, if we look at the subjective, right, we put that on a power cross. This one's a little bit easier, right? We just put that on the power cross plane on -2. We're going to get -2 axis 180, right, as our astigmatism, as our refractive astigmatism. All right, so now that we have our refractive astigmatism, we have our corneal astigmatism. Before I let you guys finish this problem, I want to go over one last thing, right? Whenever we talk about working these problems and with residual astigmatism, one thing you have to remember is that to work this, you have to have your corneal astigmatism and your refractive astigmatism in the same axis, right? It makes it a little bit difficult if you have -2 axis 90 and -2 axis 180 as your two answers, right? So what I would do if I were you is whenever I'm working these problems and I get a different axis, right, where one is 90 and one is 180, I'm going to convert both of them to 180 or both of them to 90 so that I'm comparing apples to apples and I'm not trying to compare apples to oranges. All right, guys, now that we've got these two, why don't you guys work this through and figure out what the residual astigmatism is going to be. So in this example, our residual astigmatism is going to be plano, right? Because the patient has 2 diopters of power that's needed, astigmatism power that's needed in their prescription, right? Well, we're going to create 2 diopters of astigmatism vertically, right, fitting them with an Encke GP contact lens. So in this case, the tear lens, right, will perfectly correct their subjective refraction, and that will lead us to the case where we go plus to plus, or minus to minus goes to plus plus. We will get a residual astigmatism of 0, right? So in this case, this would be the patient that we would want to think about clinically, right? If we have this patient, you would potentially think about fitting them in a GP contact lens with an Encke fit, because in the end, what you would do is you'd perfectly correct their prescription because they have no residual astigmatism. So let's talk about Duvall's rule. What does Duvall's rule allow us to be able to do? That's exactly right. Duvall's rule allows us to be able to predict the total refractive astigmatism based on only the keratometry findings, right? And so mathematically, we've got an equation that'll help you be able to do that, right? Now, there's a couple of different versions of this equation. Clinically, we sometimes use a simplified version of Duvall's rules equation, but for moving forward with the quiz questions and the SMART test and moving forward with boards, I would suggest knowing the exact calculated method, and that's what we have here in the text, equation 5.78. Right? So your total astigmatism equals 1.25 times your corneal astigmatism plus a correction factor of -50 axis 90. Now, just like with residual astigmatism, we don't want to add apples and oranges, right? We want to work with axes that are the same, right? So this equation, the way it's written there, would work for an against the rule cornea patient, right? But what's going to happen if we have a with the rule corneal astigmatism, right? So what I want you guys to write out the side is with the rule patient, right? That correction factor converts to plus 50 axis 180, all right? So a with the rule cornea patient, that conversion factor converts to plus 50 axis 180. Great. Let's continue on and talk about overrefraction. Now, we can predict we can try to figure out what the predicted overrefraction would be. We can use the GP contact lens equation to be able to do that if we're given the GP contact lens power, the ability to be able to figure out the lacrimal lens power, and then what their vertex spectacle RX is, right? And that's exactly what example 5.31 is going to do whenever you work through that example. Now, let's finish up our video session talking about some general GP contact lens parameters. So let's take it back to the whiteboard. All right, so I know this picture may look a little bit busy, but this is going to be a GP contact lens from the side, right? And I know you're thinking like, Ryan, that doesn't look like a GP contact lens at all. It looks more like a UFO, right? Flying saucer. Well, think of it like this. Think of it like we have a contact lens, we've had it sitting on the table, and we take a knife and just like slice it right down the middle, right? And so we're looking at half of the GP contact lens from the side, right? So here's going to be the front of our GP contact lens, right? And then here's going to be our back, okay? So there's our front and our back of our GP contact lens. All right. So what I want to do is I want to talk about just a couple of GP contact lens parameters, right? So whenever we think about the overall diameter of a lens, right, that's going to be the length from one end to the other end of the contact lens, right? Now, whenever we talk about the OZD, what do we think about there, right? Optical zone diameter, what is that? Yeah, that's going to be the area of useful optics for the contact lens, right? So you want to highlight that in your text. Very good. Now, remember that whenever we talk about the OZD, there's a relationship between OZD and SAG, right? If we increase, right, the OZD, right, what is that going to do to SAG? That's going to increase the sag, right? And that's also going to effectively cause the contact lens to become a steeper fit. What happens if we decrease the OZD, or we narrow the OZD and we keep the overall diameter the same? What's going to happen to our sag? That's going to decrease our sag, right? Now what's going to happen there? You're going to get a flatter fit, right? So you're going to get a flatter fit. Excellent work. So key point there, remember OZD is going to be a useful area of optics, right? And if we adjust the OZD, that's going to adjust sag, and it's going to effectively change the fit of our contact lens. Excellent work. Now let's talk about the peripheral curves, right? So we've got peripheral curves. We also have secondary curves that we want to talk about. So GP contact lenses will oftentimes have secondary curves. Sometimes they may even have a third curve in here, and it would be a tertiary curve if it's a really complicated design. And we also have peripheral curves, right? So let's focus on our peripheral curves, right? What are going to be the purposes of the peripheral curves of a GP contact lens? That's exactly right. Look in your text. You want to highlight, right? Prevents edge of the contact lens from bearing. It also promotes tear exchange. And lastly, it promotes the contact lens centration, so better centration. Excellent work. Let's keep on going. What are the characteristics of an excessive edge lift? Yeah, it's exactly right, right? They're right there in your text. You guys want to highlight that, right? Decreased contact lens centration, increased awareness of the contact lens, right? And then also particularly 3 and 9 staining, right? Cornea desiccation, right? You're going to see a lot of 3 and 9 staining because that contact lens is going to move a lot on their eye. Excellent work, guys. What's going to be the characteristics of an inadequate edge lift? Yeah, you're going to get minimum pooling of fluorescein in the periphery, right? You're also going to have a higher chance of having debris trapped underneath the contact lens, poor contact lens movement, and then also inadequate tear exchange, right? Excellent work. Now, let's go on and talk about contact lens center thickness, right? Now, whenever we look at a contact lens, whenever we think, okay, I think we need to make a change in the center thickness, we're going to do that in 0.03 millimeter steps, right? So if a question came up, like a quiz question came up, said, okay, what kind of change would need to be made in thickness, right, to make a significant change in terms of the fitting relationship of the contact lens, you would say 0.03 millimeter steps. What are the characteristics of a thinner contact lens? Yeah, thinner contact lenses are going to have better centration, right? They're also going to have increased oxygen to the eye. The last topic that we want to talk about in this video session is going to be center of gravity, right? Now, for a contact lens to have better centration, right, we want to make that center of gravity more posterior, and that's your key take-home message about center of gravity, right? This has to do with the center of weight of the contact lens, and your key take-home message is that third sentence right there that says the most posterior the center of gravity, the better the centration of the contact lens, right? All right, you guys are doing great. Go dominate the quiz, and I'll see you on the next video.